All right, good afternoon, students. Today we talked about solving equations that had variables on both sides. I'm going to do a few extra examples for you as well, uh, more than what is just on the screen or what we did in class, because I have a feeling some of you are just not completely satisfied that you know the information on this yet. So we'll just do a few extra examples that I may not have done in class. All right, so we have this first problem here. Our ultimate goal is to figure out what is the variable. What does the letter stand for? 8 plus 4d equals 5d. I want to know what is d. The problem is I have two of them. So I'm going to draw my railroad tracks to separate the left-hand side and the right-hand side so I can keep my equation balanced, because ultimately we're looking to keep it balanced. And I'm going to say, okay, how do I get to know what just 1d is? Well, I need to have just a d there. In order to do that, I'm going to have to manipulate my equation a little bit. And if I remove something from one side, I have to remove it from the other. I'm going to start looking at this problem, and I'm going to move this 4d. There's no fancy reason why I picked the 4d. I could have picked something else, but I just picked this 4d. When I do this, the 8 will still remain because there's nothing altering that. And then I have a 4d minus a 4d, and so that will turn into 0. That won't exist anymore. And then I have 5d's minus 4d, and that will leave me with 1d. Now, I could divide both sides by 1, and my final answer would be 8. It's not necessary to divide by 1 because it's not going to change anything. Dividing something by 1 leaves it the same. But that would be one way to solve this problem. Now, what I was talking about earlier is that there was no special reason as to why I chose the 4d, because I could very well have chosen the 5d also. I could have subtracted 5d from both sides. Had I chose to do that, I would have 5d's minus 5d's, and nothing would be left on this side, so I would have a 0. Over here, the 8 would remain the same, and then I would have 4d's minus 5d's. Well, if I have 4 minus 5, my answer is going to be negative because I can't take away more than what I have. So I'll have a negative 1d. All right. From here, I have the geeky friend problem that we talked about earlier. I have to solve for d, and I asked myself what's bothering it. Well, negative 1 and 8. Which one's further away? This 8. How do I get rid of it? Subtract 8. Those will go away, and it's going to leave me with negative 1d equals negative 8. Negative 1d equals negative 8. Divide both sides by negative 1, and my answer is d equals 8. All right, and that would be the answer. Same as before. Notice it doesn't matter which one I started with. Now in class we had a lot of kids say, yeah, but what if I made a mistake, or I made the choice to subtract 8 from both sides? So I subtract 8 over here, and it'll go away, and it'll leave me just with 4d. And then over here, can I subtract the 8 from the 5d? And the answer to that is no, because they are not like terms. So the only thing that you did here was just move what we would call the geeky friend to the other side. You didn't solve any of your problems. You're still going to have to move one of the d's around. So if you happen to move that first, it's not a big deal. It just added a step in there that you didn't necessarily need, or doesn't provide you with anything. All right, let's look at this problem. I have pre-drawn railroad tracks in here. Sorry about the arrows. I was drawing from far away and couldn't quite see. But let's look at this. 6n minus 1 equals 4n minus 5. Remember, you have to ultimately ask yourself, what is n? That's what I'm solving for. That's what I want. The problem here is I have two n's. I have one on this side and one on this side. So here's one and here's one. I want to get them together. It does not matter which one you choose. Myself, I'm going to choose this 4n, and to get rid of it, I'm going to subtract it. And the only reason I chose that was so I wouldn't end up with a negative number. But if you do end up with a negative number, it's not the end of the world. 6n minus 4n will be 2n. I'll drop down this negative 1. 4n minus 4n, they turn into 0. They go away. And I'll drop down my negative 5. Now this is just a simple two-step equation. Who's my geeky friend? In this case, the geeky friend is -1, so I'm going to add 1 to both sides. That will leave me with 2n, because those will cancel out, equals -4. Then I'm going to divide both sides by 2. N equals -2. If I want to make sure that I have the right answer, I can always bring this back up and plug it in and verify that my answer matches. So I found out that n equaled -2, and I'm going to plug it into each one of these to make sure that works. PEMDAS, order of operations, tells me that I need to multiply first, so that will be -12, then the -1. This will tell me to multiply first also, so that would be -8 minus 5. I don't like to subtract, so I was going to do tick-tock. -12 plus -1 is -13. Tick-tock. -8 plus -5 is -13. They equal each other, so it's right. That one's a little easier, so I'm going to skip down to one of these more challenging, one that has all the parts here. 3x minus 7 equals 8x plus 23. Again, draw my railroad tracks. My ultimate goal is to figure out what x is. When I have two x's, it's very difficult to solve, so I need to combine them. I notice this 3x over here, and I want to subtract it over here so I don't end up with a negative variable. So I'm going to subtract the 3x and subtract the 3x. Would it matter if you subtracted 8x first? No. What if I added 7 first? That's fine. You will get the same answer, and go ahead and try that. Try doing it a different way and come back and see if you get the same answer I do. 3x minus 3x will cancel out. I'll drop this down. Just make sure you note that that negative sign comes with it. 8x's minus 3x's, well, 8 minus 3 is 5, so that tells me I have 5x's left over here, and this positive 23 is just going to drop down. I'm going to subtract the 23 from both sides. Again, that's like the geeky friend I talked about. I need to break up that date, or get rid of them. And when I do that, this will leave me with a 5x on this side. And -7 minus 23 is -30 on this side. Finally, I need a divide to get that x by itself, and that will leave me with a -6. Again, doesn't matter how you solved it. You may have gone a different way, but that would be your answer. Please don't be frightened of fractions. And I'm going to throw a different fraction problem in here just so you guys would be able to see one, but I actually don't see another fraction problem right on my mind, right on my paper here. So I'm just going to skip that. But I am going to try adding some other pieces in, because you are going to run into problems like this. So let's go with 2 parenthesis x plus 6 equals 3 parenthesis x minus 9. Now this may turn into a decimal answer. It may not be perfect. I just completely made it up. So we'll just have to work with that. And it's okay to get decimal answers and fractions. But the first thing I have to do here is get rid of these parentheses. Later on, you'll learn another step that, would help you with that. But right now, where we're at in pre-algebra, the first thing I have to do is distribute. I need to deliver this newspaper to everybody on the block. 2 times x is 2x. 2 times a positive 6 is a positive 12. 3 times x is 3x. 3 times a -9 is -27. So now I ask myself yet again, what am I solving for? X. In this case, there are 2 of them, so I need to get them together. To get these x's together, I'm going to take this 2x and move it over here. Again, no special reason other than it'll allow me not to have negative x's, but I could have done something differently. The 2 x's are going to cancel out, leaving me with just the 12 here. 3 x's minus 2 x's is 1x, and this 27 is going to drop down. Now I need to get rid of my geeky friend, and I'm going to do that by adding 27 to both sides. The reason I'm adding 27 is if I circle the number and sign in front, that's a negative. I added 27 to both sides, and over here I get a 39, and on this side I get a 1x. I could divide both sides by 1, but it's not going to change anything, so that would be my final answer. All right, I am going to give you 1 or 2 word problems here before we go. This first word problem is interesting to me, and the only reason it's interesting is when the book was written and being published, this was how cell phone bills were calculated, and they're not calculated that way anymore, so it might not make complete sense to all of you, but let's still work through it. Maybe they'll go back to this method at some point in time. A cell phone provider charges $24.95 per month plus 10 cents per minute for calls. Another cell phone provider charges $19.95 per month plus 20 cents per minute for calls. How many minutes of calls, because I'm solving for minutes, is the monthly cost of both providers the same? So how many minutes will the cost be the same? If they're the same, they have to equal each other. So I will have calls for provider 1, they have a certain plan, and provider number 2 has a second plan. I want the 2 plans to equal each other. So I'm going to take and solve $24.95 plus 10 cents per minute and $19.95 over here plus 20 cents per minute. And then I'm going to apply all those same steps. I want to solve for the minutes, so I want to get them together. When I get them together, I'm going to subtract 10 cents per minute from both sides. That means this side's going to go away, and $24.95 is going to be over here. That's the only thing that remains. $19.95 over here plus 10 cents per minute, because when I subtract those, that's what I would get. I'm going to subtract $19.95. I'll get $5 on this side equals 10 cents per minute. Then I would divide both sides by 0.10 or 10 cents. And doing my math quickly, I believe it ends up being 50 minutes. The minutes ends up being 50. I'm running out of time, but I am just quickly going to show you how to set up one more problem like that. We'll talk about renting cars. Maybe you go on vacation and you have to rent a car when you're there. We have 2 car rental places. One is Easy Car Rental. They charge $40 a day just to have the car in your possession. And then if you drive it around, they charge you 25 cents per mile. We have Ace Car. They're only going to charge you $25 a day, but they're going to charge you $45. You want to know at what point are these 2 going to be the same? Because if you drive less than that, one will be a better deal. If you drive more than that, the other one will be a better deal. So we want to look at where are they going to be the same. So I want Easy Car to equal Ace. In order to do that, I go back up to Easy Car and I notice that it's $40 a day plus the 25 cents per mile. I look at Ace, they're $25 a day plus 45 cents per mile. And then again, due to time, it's going to kick me off here in a second, but I would then solve my railroad tracks and move all of this around and be able to solve that problem. Please make sure that when you are moving problems around and moving variables around that you're paying attention to the sign. What sign is it? And so if I had another problem where I had m minus 18 equals 3m, and I'm going to solve this, know that this negative sign goes with the 18 because I circle the number and sign in front. So with this m would be a positive m, and then to manipulate that I would subtract n from both sides. Alright, I thank you so much for watching, and I hope you have a great success on your homework. See you tomorrow.